Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, please subscribe to the channel, give this video a thumbs up, and please feel free to engage with comments below. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 8, Equivalent Quadratic Expressions. The learning goal today is to use diagrams to help us rewrite quadratic expressions. We have one learning target. At the end of the lesson, we'll come back and review this learning target and make sure that you understand everything you need to have success moving forward. The learning target today says that you can rewrite quadratic expressions in different forms by using an area diagram or the distributive property. Our first practice problem says draw a diagram to show that 2x plus 5 times x plus 3 is equivalent to 2x squared plus 11x plus 15. And when they're saying to draw a diagram, we can use what we call an area diagram. So I'm going to draw a box, and I'm going to split it into 4 sections. And across the top, I'm going to put the first factor, 2x and 5. Then down the left side, I'm going to put the second factor, x and 3. The idea behind what we're going to do here, some of you may have done before in biology when you look at Punnett squares to do gene mutations or to determine what genes offsprings of two parents might have. So what we're going to do is we're going to take whatever's at the top of the column and we're going to multiply it by each thing that's on the left side. So 2x times x would be 2x squared. 2x times 3 would be 6x. 5 times x is 5x. And 5 times 3 would be 15. Now we're going to add all of these together. So we have 2x squared plus 5x plus 6x plus 15. Now we can join like terms. So we have 2x squared, then 5x plus 6x equals 11x plus 15. And we see that this exactly matches what they said it would be equivalent to. So anytime they ask you to draw a diagram to show that the factored form is equivalent to the standard form, this is what they're talking about. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 says to match each quadratic expression that is written as a product with an equivalent expression that is expanded. So on the left side, product means that we're multiplying two things together. and we would call this the factored form. On the right side, they say that this has been expanded because we've multiplied the two things together, and now we've written it in what we would call standard form. So in order to do this, we're going to use something that we call FOIL. First, outside, inside, last. So we're going to take the first term, x, and multiply it by the other first term, x, and that gives us x squared. We're going to take the outside term, x, and we're going to multiply it by the other outside term, x times 6 equals 6x. Now we take the inside term, 2, and we multiply it by the other inside term, x. 2 times x is 2x. And finally, the last term, 2, multiplied by the other last term, 6. 2 times 6 is 12. So what we want to find is x squared. We can add 6x plus 2x so that we get 8x plus 12, and we see that right down here with number 4. Now for b, we'll do the same thing. 2x times x is 2x squared. 2x times 2 gives us 4x. 8 times x gives us 8x. And 8 times 2 gives us 16. So we add 4x plus 8x and get 12, and we have 2x squared plus 12x plus 16, and we see that here in number 3. Choice C. We have x times x, which is x squared, x times 4, which is 4x, 8 times x, which is 8x, and 8 times 4, which is 32. So we have x squared plus 12x plus 32, which we see in number 1. And lastly, choice D, we see x times 2x, which is 2x squared, x times 6, which is 6x, 2 times 2x, which is 4x, and 2 times 6, which is 12. So we're looking for 2x squared plus 10x plus 12, and we see that with number 2. If you have any questions about how to take a factored form and multiply it together to get the standard form, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 3. Select all expressions that are equivalent to x squared plus 4x. To solve this, we're going to use the distributive property and see if each of the choices matches the one they give us at the top. So, on choice A, if we use the distributive property, we have x times x, which is x squared. Then we have x times 4, which is 4x. This does match what they gave us at the top, so A is a correct answer. Choice B, we have x plus 2 squared. This is the same thing as x plus 2 times x plus 2. Now we can use the FOIL method. So we have x times x, which equals x squared, x times 2, which equals 2x, 2 times x, which is 2x, and 2 times 2, which is 4. We combine the like terms, and we get x squared plus 4x plus 4. This does not match what they gave us at the top, so B is not a correct answer. Choice C. We take x times x, and we get x squared. X times 4 is 4x. X times x gives us x squared, and x times 4 gives us 4x. We combine the like terms, and we end up with 2x squared plus 8x. That does not match what they gave us at the top, so C is not an equivalent expression. Choice D. Here we have x plus 2 squared minus 4. So this is the same thing as x plus 2 times x plus 2 minus 4. X times x is x squared. X times 2 is 2x. 2 times x is also 2x. And 2 times 2 is 4 minus 4. We can combine the like terms, and we end up with x squared. 2x plus 2x is 4x, and 4 minus 4 is 0. So we have x squared plus 4x. That does match what they gave us at the top, so D is an equivalent expression. And our last choice, x plus 4 times x. We have x times x, which is x squared, and we have x times 4, which is 4x. So we end up with x squared plus 4x. That matches what they gave us at the top, so E is an equivalent expression. If you have any questions about how to determine if two expressions are equivalent, please leave a comment below, and I'll get back to you with any help that I can offer. Our last practice problem, Tyler drew a diagram to expand x plus 5 times 2x plus 3. Number 1, explain Tyler's mistake. So let's look at Tyler's work and find his mistake. On the top, we have 2x and 3. And this comes from the second factor. So that is correct. Down the left side, we have x and 5. That comes from x plus 5. So that is correct. Now let's multiply what is at the top of each column with what's to the left of each row. 2x times x equals 2x squared. That's correct. 3 times x is 3x, so that is correct. 2x times 5 should be 10x. So this is wrong. It should say 10x. And 3 times 5 should be 15. So this is wrong. So Tyler's mistake was that 2x times 5 should equal 10x, and 3 times 5 should equal 15. Now, for number 2, what is the correct expanded form? We have 2x squared plus 3x plus our corrected answer in the bottom left of 10x plus our corrected answer in the bottom right of 15. We combine the like terms and we end up with 2x squared plus 13x plus 15. And this is the correct expanded form. If you have any questions about this practice problem or any of the practice problems that we've gone over in this lesson, please leave a comment below and I'll get back to you with any help that I can offer. Now, before ending this lesson, let's go back, take a look at the learning targets, and make sure you've learned everything that you needed to be ready moving forward. Looking back at our learning target for this lesson, it said that you can rewrite quadratic expressions in different forms by using an area diagram or the distributive property. If you think about the practice problems we did, the area diagram is where we drew a box that had 4 segments. Across the top, we put one of the factors, and down the left side, we put the other factor. Then you multiply what's at the top of each column by what's on the left of each row, and you put their answer in the corresponding box. Once you find those 4 parts, you add them all together, add the like terms, and you have your expanded form. We also looked at how to use the distributive property, both by using the FOIL method and by simply distributing whatever was outside the parentheses to each item inside the parentheses. If you still have any questions about anything we covered in this lesson, please leave a comment below and I'll get back to you with any help that I can offer. If you found this video helpful, please hit the subscribe button, give this video a thumbs up, and on the screen you should see another video that YouTube believes you will find helpful. I look forward to seeing you in the next lesson.